Dear students, now we are going to see problems on Thevenin's theorem. So this is a problem statement. Determine the Thevenin's equivalent circuit across the AB terminals for the circuit shown in the below figure. So this is the circuit diagram they have given, and we need to find the Thevenin's equivalent circuit across these AB terminals. So for that Thevenin's equivalent circuit, first step is we need to find the Thevenin. So in order to find the Thevenin, so what we need to do is we need to calculate the voltage across these AB terminals. So we need to calculate the voltage across these A and B terminal. In this circuit, now we are going to apply Kirchhoff voltage law. So what is the Kirchhoff voltage law? The algebraic sum of the voltages in a closed loop is equal to 0. So the voltages across this loop is equal to 0. So first of all, the current is entering at this voltage source. It is entering at minus terminal. So the voltage will be plus 50. Then the resistance, voltage across these resistance will be I into R. What is the R? That is 10. Next, the voltage across these 5 ohms resistor is minus I into 5. Next, this voltage source, for this voltage source the current is entering at the positive terminal, so we need to consider this one as minus 25 is equal to 0. Okay, if you see here, this equation, both are same. Okay, the only thing is they have taken these 50 volts at the last, remaining everything is same. So from this, on simplifying these equation, then we will get 15I is equal to 25. Therefore I is equal to 25 by 15. If you simplify that, you will get the I value as 1.67. So now we need to calculate the voltage between the point A and B. That is nothing but the open circuit voltage across the AB terminals. So I am going to draw the equivalent circuit for that. So the 10 volts resistance I am going to draw here, and the 50 volt voltage source I am going to draw here, and this will be the A terminal and this will be the B terminal. Okay, similarly if I draw the circuit on the right side, then it look like this. Okay, so now we need to calculate the voltage between these A and B terminal, that is nothing but the Thevenin. This is nothing but the Thevenin. So these voltage value will be equal to voltage of these two or voltage of these two. Why? Because all these three are in parallel. Okay, all these three are in parallel. So now what we need to do is, I am going to calculate the left side value, that is 50 volts. Here it is 10 ohms. So if I calculate voltage of this left side branch, then it will be equal to 50 volts minus I into 10. So what is the I value that we got? The I value we got is 1.67 amps. So we need to substitute that I value here. So if we substitute I value there, then you will get 1.67 into 10. Okay, on simplifying this, you will get 33.3 volt. So we have calculated the Thevenin. Now we need to calculate the Thevenin. So this is very simple one. So while we are calculating the Thevenin, the condition is the voltage and current sources should be replaced by its equivalent resistance. So in this circuit they have given two voltage sources. This is one voltage source and this is another voltage source. Now what we need to do is we need to replace that voltage sources with short circuit. Why? Because for voltage circuits the equivalent resistance or equivalent circuit is the short circuit. So I am going to replace those two voltage sources with a short circuit connection like this. Now if you see here, I can redraw this circuit as, this is the 10 volt, right? 10 ohms. This is the 10 ohms, and this resistance also I am going to draw at this place. This will be the 5 ohms. So this is the A terminal and this is the B terminal. Now here I need to calculate the R Thevenin value. So R Thevenin is the equivalent resistance of these two parallel resistors. So what is the formula for calculating the equivalent resistance when the resistance are in parallel is? So we know that 1 by R equivalent is equal to 1 by R1 plus 1 by R2. So by using this formula we can calculate the equivalent resistance, that is nothing but the R Thevenin. So finally we got the R Thevenin. So in this problem we have calculated the V Thevenin and R Thevenin. So then we can draw the equivalent circuit for this given circuit. Okay. So finally the Thevenin equivalent circuit is nothing but V Thevenin in series with the R Thevenin. So this is the thing that we need to calculate. That's it. Thank you.